On behalf of DSIMS and DSGS, I would like to extend a very warm welcome to all of you for the 10th edition of our signature conclave, Opsession 2021. Over the past decade, it has been our endeavor to orient the themes of this conclave to the future, recognizing as we do the imperative of making our students more aware of new and emerging technologies and trends that will impact their future careers. Thus, in earlier years, the conclave themes have been supplying the future, digital transformation of industry, enabling Make in India, blockchain technology, digital factory, electric mobility, and this year, Hyperloop, the future of transportation, and cloud and collaborative technologies. In July 2012, Elon Musk, the co-founder of Tesla Incorporated, envisioned a revolutionary transport system, the Hyperloop, in which passenger-packed pods would travel through long tubes at up to 1220 kilometers per hour using magnetic levitation in near vacuum conditions and linking city pairs up to 1500 kilometers apart, like LA and San Francisco. Cloud collaboration, as we will observe, is a method of collaboration where multiple individuals may access, review, and edit documents in real time. The documents are housed in the cloud, always versioning, so that all individuals with access observe changes as they are made. Companies investing in cloud collaboration can experience up to 400% ROI. We are fortunate to have with us today leading thinkers with expertise in these thematic platforms. We extend a very warm welcome to Dr. S.R. Chakravarti, Dr. Guru Prasad Rao, Mr. Sudev Mandal, and Mr. Sukant Upadhi. I would now request our program hosts to kindly take the proceedings forward. Thank you, ladies and gentlemen.
Thank you, sir.
May I now request our director, DSIMS, Dr. C. Babu, to address this event.
Thank you, Mithali. The conclave obsession convener, Professor Somesh Banerjee, my co-director, Dr. Sarita Vichore, the august experts, the guests, the luminaries, Dr. Chakrabarti, Dr. Guru Prasad Rao, Mr. Sudev Mandal, Mr. Sukanta Pathe, and my dear faculty colleagues, the student volunteers of Opsession, and last but not the least, my dear students. This is the final edition of the conclave of the 4 conclaves that we had. This is the 4th conclave. And I love the topics. These 2 themes are, very close to my heart, but I cannot speak more than 2 minutes. We have all the experts, and my hunger to know more about these themes are insatiable, as you all are waiting for. So I'm also, like you, waiting to hear from all these excellent experts. But in the meantime, one quick observation: this new paradigm, you call it, or the new norm, has given enormous opportunities for our students. As I said, this is a 4th conclave, and our students, every week, almost every week, they get fabulous opportunities to listen to all these experts. This is something I consider a new opportunity. Otherwise, it's almost difficult, if not impossible, to get all these luminaries of great knowledge and geniuses to come on one board like this. So I'm really thankful, and I take this opportunity to welcome on behalf of my chairman, Mr. Ashok Chara, and RSCT. You know, this trust has got 16,000 students. We have got more than 20 institutions. So DSIMS and DSGS, we feel proud and honored to have all these honorable speakers for this particular function. I wish this obsession a grand success. Thank you and have a good day. Thank you.
May I now request our Director, DSGS, Dr. Sarita Vichore, to address this event.
Thank you, Varsha. Very good morning to Team Obsession, convener Professor Somesh, Professor Harshad, Dr. Sadhna, and the team of students who are working behind it. A very good morning. My very good morning to the panelists, Dr. Chakravarti, Dr. Guru Prasad Rao, can see Mr. Somin Mandal, can see Mr. Sukanta Padhe around, and very happy to see luminaries and experts coming on this platform to share on the topic which is very interesting and has become very in due to the pandemic that we have seen, cloud and collaborative technologies and Hyperloop future of transportation. Let me tell you, cloud and collaborative technologies have been immensely used by the education institutions in these times when education was imparted from home. We all could understand that what is required is cloud, keeping all our data, using the space, and thus sharing it. So what can we say of Hyperloop future of technology? What we are looking at is a sustainable way of transportation, a fast way of transportation, and environment-friendly transportation, which is the fifth mode of transportation that we are looking forward to in terms of innovation and disruptive technology in India. We all know that we face problems in terms of costs when we talk of rail, road, water, and air in the supply chain side of it. And if we get this opportunity to get into a Hyperloop way of transportation, nothing like that. So would like to know more about it. Very warm welcome to each one of you. And thank you for selecting such a good topic. My congratulations to the whole Obsession team for selecting such a topic, and more we would like to know. I would like to address one more thing of the management school that we belong to, DSIMS and DSGS. This is the fourth functional conclave. Previously, we had 3 functional conclaves. We had HR, we had finance, and we had marketing. Until date, we had interacted with 20 plus experts along with the students, and the learning was immense. These kinds of initiatives come under Industry Institute Partnership Cell at the Institute. And for DSIMS, this is the 11th year that we are trying to progress and make the managers the leaders of tomorrow. This wouldn't have been possible without the support of the experts that we get at the Institute and their contribution to the Institute. So a heartfelt thank you to each one of you for making it possible for us. Thank you, Varsha. Over to you, and wishing you all the best to see that we learn more.
Thank you so much, ma'am.
It gives us immense pleasure to welcome all the dignitaries, invitees, faculty members, alumni, and all our fellow students.
Now, may I politely request to all our speakers to adhere to the 30-minute time slot indicated in the program schedule.
We would like to introduce our first distinguished speaker, Dr. S.R. Chakravarti. Dr. Satya Chakravarti is a professor of aerospace engineering at the Indian Institute of Technology, Madras, India. He received his Bachelor of Technology degree in aerospace engineering in 1991 from IIT Madras and went to obtain his Master of Science in aerospace engineering in 1992 and PhD in 1995, both from the Georgia Institute of Technology, Atlanta, USA. Dr. Chakravarti works in the areas of propulsion and combustion and researches on different aspects of combustion in gas turbine and rocket engines. He heads the National Center for Combustion Research and Development, NCCRD, at IIT Madras. Currently, Dr. Chakravarti is also heading the Center of Propulsion Technology at IIT Madras. He has around 100 peer-reviewed archival journal publication to his credit and has presented over 240 conference papers and delivered many keynote, plenary, invited lectures, visited many universities such as MIT, Cambridge, TU Berlin, and TU Munich, and industries such as GE and FM Global. Dr. Chakravarti is the director of the E-Plane Company, a startup company aiming to make a new breed of aircraft called hybrid aerial vehicles for very vertical takeoff and landings, as well as long distance flights to carry goods and passengers, ultimately leading to air taxi operations. He is also the faculty mentor of the Avishkar Hyperloop student team at IIT Madras. Now I call upon Dr. S.R. Chakravarti to share his thoughts with us.
Thank you very much, Mitali. Let me just, I suppose I'll be allowed to share screen, right? Yes. Are you able to see my screen?
Yes, sir.
Yes, sir, we are able to see it.
Very good. Yes, let me start my talk. Thank you very much for this opportunity. It looks like a very wonderful event that you're organizing here, and wish you all the best for this. The topic that has been given to me today is to talk on Hyperloop, which is a very exciting topic. So what we would like to cover is future of passenger as well as freight transport with Hyperloop in the next 20-30 minutes. Let me just check. Having a little problem trying to, okay. Yeah. So let's just start with what's Hyperloop. It's the next big thing, as they say in a lot of things. So this is actually the next big thing in the transportation industry. And I think as has been mentioned before, it's the fifth mode of transportation. And this minimizes energy losses in to air drag and wheel friction. This is typically about capsules that can travel in vacuum tube at speeds greater than about 1,000 km per hour, which is actually greater than what an airplane can do, and with frequency of metro trains. In fact, I would like to call Hyperloop the intercity metro. So we would essentially be looking at metro kind of thing, interconnecting a lot of cities is what this is all about. The feasibility and scalability of the concept have been demonstrated on multiple occasions. So the first occasion was Elon Musk releasing this Hyperloop Alpha white paper. The SpaceX pod competition actually has accelerated the growth of the ecosystem that's been conducted a few years through about 2017 to 2019 at Hawthorne, near Los Angeles. It has in fact spawned quite a few startups that have now evolved into major companies, like Virgin Hyperloop One is one of those, Heart Hyperloop another one, for example, HTT third one, and so on. So recently, Virgin Hyperloop actually showed a first human test of a fully functional setup. So what is why Hyperloop, right? So here we have the Indian map where we are suggesting a few different points. Of course, that this is not exhaustive by any means. These are essentially suggested. right? And I think there are people there are groups that have worked on these kinds of these particular routes. So there is a dire need to invest in new sustainable technologies, and this talk is a proof for that. Uh, the energy needs of Hyperloop are actually low enough to be met by solar power generated by its own infrastructure. Thus, it's actually self-sufficient and has a net negative carbon footprint upon implementation. With city congestion and demand for transportation set to keep rising, Hyperloop will make intercity commute easier and faster. So what exactly does it mean? For example, if you now look at a transit between Chennai and Bangalore, which is 6 hours for a 350-kilometer journey by train, it's 2 hours plus security check in and out by airplane. The actual flight is only about 40 minutes, but you have to go to the airport, get to the airport, and get back from the airport to your place and so on. So it takes nearly more than 2 hours. It's about 3 to 4 hours. And whereas we are actually talking about going into the middle of the city from the middle of the city in 30 minutes flat. This commute is fast, safe, and comfortable. And also we will find that this is very economical and it can do bulk transportation. So, so as we were talking about the Chennai-Bangalore case study, let's actually look at a little bit more details. So we have done calculations, for example, here showing a Chennai-Vellore Bangalore route, which can be like a template for the subcontinent. A pod equipped with the latest technology is proposed to weigh about 20,000 kilograms. Two types of proposed pods, passenger and freight, will run intermittently. So when you say intermittently, it's actually more like on demand, which is sort of like a very more effective capacity utilization. So Hyperloop opens up the world new possibilities, such as commuting to cities like Bangalore from small cities like Vellore. So essentially, a lot of satellite townships and all those things can be managed very well. It reduces the travel time between offices in Delhi and Bangalore to 1 hour, which means people in Bombay can actually go to work in Delhi and come back in the evening and vice versa. Right. So typical specs are max, as I said, pod weight is like 20 tons. Max acceleration is 0.5 g. Minimum distance between pods is about 25 kilometers. Time gap between two pods could be as low as 2.5 minutes. Sometimes we are even looking aggressive at half a minute. Minimum time at station is about 2.5 minutes. Total number of pods required would be 28, and Chennai to Bangalore time is about 30 minutes. In fact, I think this is very conservative. We can actually drive it up to 15 minutes. So the passenger, let's actually look at the passenger Hyperloop and then go to the freight Hyperloop. This proposed pod has the capacity to transport a significant portion of the intercity traffic, will prove resilient to rush hour traffic. Energy needs of Hyperloop are low enough. I think we mentioned this. We can actually do solar panels on the infrastructure for catering to it. The energy per passenger is at par with that of train, but annual solar energy production exceeds requirement by about 50%. So we have significant advantage over there. As demand rises and the research progresses further, pods will be upgraded to higher capacity. So today, for example, if you now look at a pod of capacity about 75 people per pod, and we can actually get maximum departures from a station to about 1,800 persons per hour, which is on a daily basis for about 18 hours of operation, a two-way traffic of about 64,800 people. By comparison, the daily two-way traffic between Chennai and Bangalore in 2019 was about only 44,000, which means that we can put in place a capacity that exceeds the current demand and can fulfill future demand significantly. So Hyperloop provides a radically different travel experience than conventional modes of transport. Passengers will consider it only when it's significantly faster and at the same time cheaper than most other modes. So the cost is something that we have not yet talked about, but we will actually find that it's comparable or even lower than current train costs and flight costs. Reliability, there is frequency of service, capacity, ticketing systems is also a crucial factor. So here are some couple of pictures that actually show how cool it is to be traveling in a Hyperloop. What are the benefits? Right? Hyperloop will help bring the world a little closer by drastically reducing the time required for traveling between far-off cities or even countries. Currently, the fastest mode for such a travel is by air, which is pretty expensive and involves a lot of hassles and waiting times, security checks. Hyperloop can provide the same service at a lesser cost and minimal time wastage. So you can imagine the kind of security checks that you go through in metro stations, and we would be able to implement that kind of thing here. So this reduced risk, reduced time of travel will enable people to seek employment opportunities in a different city than where they live. The huge infrastructure for Hyperloop, including tubes and Hyperloop terminals or stations, will generate numerous economic opportunities for the people. Challenges. What are the challenges for passenger Hyperloop? Although several tests of Hyperloop system have been done, even with passengers, still there is considerable need of research required to improve it and make it economically viable. I expect personally that within about 5 years, this R&D phase would be over, and we will start implementing full scale within the next 5 years, which means that within the next 10 years, through this decade, we should actually have full scale implementations of Hyperloop happening around the world. Now, the characteristic properties of Hyperloop require huge capital because we are looking at evacuated tubes running long distances. And the risk profiles and the long financing period prior to expected returns might discourage potential investors. What we are doing here at IIT Madras is to disrupt this with trying to make this capital cost about 1/10th to 1/20th of what it is currently today. And that will try to make the time for the rate of return actually better, and the break-even time to somewhere between 7 to 15 years, depending upon whether it is 10 times or 20 times. So that's and that's reasonable for like an infrastructure kind of thing. So safety systems in the vehicle to be provided for emergency situations, because it's actually evacuated pod. We will have vestibules at the stations, but what if something goes wrong in between, and how do people get out of there? Something that we have to worry about. Since there is huge accelerations involved and no external view, passengers' comfort and recreation are also needs to be focused on. So these are the soft things that we have to worry about. Let's actually turn our attention to freight Hyperloop. The freight pod will have the same systems as passenger. So for one of the things that we don't have to worry about too much is the aesthetics of what will happen in a closed space. For passengers, freight doesn't care about it. Freight is less sensitive to safety, although we need to make sure that we are indeed delivering on the goods. So Hyperloop will be valuable for fast transportation at cheap tariffs in the age of commerce. So we have to actually look at which freight is actually more time sensitive, because most freight may not be really time sensitive. So we will have to spend quite a bit of time thinking about this. The scale of systems currently being developed cannot displace the conventional modes like train. We will make some comparisons and point out that we are really, it's not as competitive as for passengers, because there are two things about people versus freight. One is people actually care about time. Freight, there are only a few situations where we will have time sensitive freight movement. The second thing is when people actually get into the pod and travel and get out of the pod, they can actually move themselves out and then take another transportation to that point of destination. But freight requires attention for us to now again move it from the point of delivery of the railway, the Hyperloop station to the point of delivery, which means that there is like last mile connectivity issues that come with freight that's more significant than work with passengers. So as research progresses, pods will, with the high capacity, will account for high passenger and freight demands. Again, if you now look at the 75 passengers per pod analogy here, we can now think about a 7,500 kilogram per pod, and the hull capacity during night times, like say the same pods, for example, if you now use or let's say the same infrastructure, instead of 18 hours of passenger movement, if you use 6 hours of this one, what do you call freight movement, you can actually move about 1,080 tons, which is very close to like what a railway does with 2,200 tons. So this is in the ballpark. So as you now improve capacity, competing with passengers, you can actually meet these targets fairly easily. So what are the benefits here? The freight pod will drastically reduce the delivery time. Consumers want faster delivery and businesses want a more efficient supply chain. So e-commerce companies will look for growth and the customers expect rapid deliveries from them. With freight Hyperloop, both the parties are better off. So this is a win-win situation. Lower shipping cost than airplanes is actually the key advantage here. Airplanes and only 1.5x more expensive than trucks. Greater efficiency to the warehouses due to a faster movement of the goods. This is one of the logistics conundrum. So this will have the businesses cut on costs as they will reduce the finished goods inventory and therefore the need for bigger warehouses. So this is a very good balance that we can actually strike. Safe shipment of goods. The freight hyperloop is susceptible to harsher weather conditions when compared to air. So this is actually more foolproof. What are the applications of freight hyperloop? So we talked about e-commerce. Let's consider this a little bit more, and then a few others, and we'll also show some data. E-commerce businesses can deliver the shipments quicker through freight hyperloop and reach to a larger consumer base. In fact, I can also use this to advertise the other thing that we are working on, which is like from the hyperloop station, which you now transport things in about a few minutes. You can now also do urban air mobility, and then get to people's homes, right? So that's a very much easier way of doing this. Perishable items like food can be transported quickly through the freight hyperloop. So cooked food from one place to another city completely can actually be moved. The freight part will come handy during medical emergencies like shifting patients, medical equipment, immediate life support and resuscitation of critically ill and injured patients. And we can also have, so the next couple of points are again related to quick transportation of organs and organ donors towards the recipients during the emergency situations, or quick transportation of doctors from one hospital in one city to another during cases of critical emergency. Live animals can be transported when they need immediate life support. Some of the endangered species can be rescued from extinction. Spare parts for the aerospace industry can be delivered in a quick span when they need some components in emergency situations like avoiding accidents. Now, how do we compare this with other modes? If you now compare with air, the most possible market for Hyperloop service will be freight currently served by air. So this is like a direct competition here across drastically at the moment. So air networks use a hub and spoke network for freight delivery. The flexibility of air transport not having a fixed guideway enables the hub and spoke system, but the Hyperloop uses point-to-point network. In some sense, point-to-point will be more effective in the long run, but infrastructure heavy to begin with. Hyperloop would need a high-density channel for freight movement between a specific origin and destination pair to support a Hyperloop investment, which essentially means that we should be looking at these high-density corridors first, and then once you actually put up a infrastructure in these corridors, then you span out away from the corridors into the hinterland. If you now compare with truck, doesn't really do a good job. Hyperloop will be unlikely to take market share from truck. Short distances will be covered by truck much quicker and cost effectively. Using Hyperloop will still require the truck service at the origin and final destination. The last mile, the first and last mile problems exist. As I said, we could actually couple this with urban aerial mobility transportation solutions for quicker deliveries. Rail. Hyperloop will likely not cut into the rail market significantly. This is for slow-moving freight. There is a lot of slow-moving freight out there. So freight rail service is advantaged when moving a heavy, bulky cargo that is not time sensitive. Now, what about water? Ships are as a transport mode are cheap. They are very time consuming. Most ports are capacity constrained. This is a huge problem that a lot of people do not quite acknowledge. Many ports are actually capacity constrained, and there are long waiting times for just unloading the freight from the ships. And so just because the freight is not time sensitive, we're just kind of like taking advantage of it, abusing it rather. Hyperloop can facilitate these offshore port activities by quick distribution of the freight to inland regions. So they're very similar to how warehouses can be cleared very quickly. We can also clear ports if we. So what is the opportunity for Hyperloop? The e-commerce sector is going to be one of the major area that Hyperloop would have an immediate effect on. Hyperloop can increase the speed of delivery considerably. Global same-day delivery market size is currently over about 4.6 billion USD, and it is expected to grow at a whopping 20.3% CAGR from through the 2020-2027 period. That's the estimate, right? So you can see this growth curves over there. Now, according to a study, this is very, very important. According to a study, over 75% online shoppers desire same-day delivery. Over 40% online shoppers are willing to pay extra for the same-day delivery, but only a little over 50% of the companies offer same-day delivery due to technological difficulties. And this is exactly what we find over there. So the economic opportunity of the Hyperloop here, major economic zones could travel in and out. Transportation networks would be strengthened and widened. A study by Hart Hyperloop suggests that if Amsterdam was connected to Groningen, The Hague, and particularly regions such as the rural area by the Hyperloop, there would be an additional GDP of about 275 billion euros for a province. That is growth of about 121% positive. An analogous situation would happen anywhere. There's nothing specific to Amsterdam or the Netherlands. This can actually happen in India just as well. Hyperloop industry also provides huge job opportunities. The Pune-Mumbai Hyperloop would create 1.8 million new jobs in the Maharashtra region. There's nothing like anything like this, to compete. The Pune-Mumbai project could reduce greenhouse gas emissions by about 150,000 tons annually as a result of the electric powered track and reduced traffic congestion. And being fast and cheap, Hyperloop offers students more educational institutions to choose from, significantly reducing the geographic constraints. Many times, students are the ones who actually face the geographic constraints because they're still too young and parents are unwilling to send them to far off places, particularly girls. And Hyperloop actually can be a significant boon in that sense. Challenges. What are the challenges for freight Hyperloop? Significant testing is necessary to fully understand how the technology could be certified for freight transport use. This is a little less taxing when compared to passenger, but still this problem exists. Again, the next 2 to 3 years, 3 to 4 years is actually key time frame for overcoming this particular hump. Limitations to the size, weight, load, and design of the pod are likely to impact the cargo. Again, if you are 7,500 kg per pod is not a bad deal at all to transport. The currently developed tube diameters and pod designs would be unable to accommodate traditional road, rail, and sea cargo containers. So we may have to transform that part for larger freight. But I think to start with, we can actually try to complement the passenger movement infrastructure for freight over about a 6 to 8 hour period in a day. As such, new containers would be needed, incurring additional costs and delays due to repacking on any trips involving multiple legs if you're actually trying to use containers. For example, the ones from the ports will require containers, and right now, these tube diameters are meant for passengers. So due to the lightweight design of the pods and the sensitivity in calibration for magnetic levitation, balancing the weight of any components would also require careful loading and weight distribution, which could also slow the loading process. But this is a problem that exists with aircraft anyway, and that's been surmounted in aircraft all the time. And so we can overcome this. It's not a big problem. A significant number of freight sectors have additional requirements. Example, climate control or protective casing. How Hyperloop capsules might handle such requirements is still unknown. Usually this is done by customizing parts, and so that will actually mean something additional to start with, but actually very effective in the long run. So what is the sustainability of Hyperloop? Hyperloop has been designed to be sustainable mode of transportation due to there being a zero emissions and low energy consumption. In fact, it's actually a net negative carbon, not even carbon neutral, it's actually negative carbon. So the electricity to run Hyperloop is proposed to be generated using solar energy through solar panels fitted in the Hyperloop tube and other infrastructure. Additionally, wind energy could also be utilized to power Hyperloop. Of course, this will also mean that we need to make significant this will result in almost zero carbon footprint for the system. Use of such renewable energy will help to make it self-sufficient and environmentally friendly. If all passenger flights for short to mid-range distances are replaced by Hyperloop, we could cut back on a significant percentage of the pollution. I think lastly, we need to worry about safety and comfort. Safety and comfort of crucial factors that have had little progress as of now, because we are still on the technology development curve, not got to this point yet. While traveling at such high speeds, even a minor error could actually lead to catastrophic results, and the outside pressure being very low, below the atmospheric pressure, also adds to this concern. So it's sort of like we are creating a corridor by means of a tube, and recreating space-like environments on Earth. So and space environments are definitely hazardous. So there is some amount of space technology to be borrowed from over here, and we need to think through that. So added to this is the danger of natural calamities like floods and earthquakes, which could affect Hyperloop infrastructure such as tubes. So when we now try to make tubes less expensive, and which means that they could actually become flimsy, they might be susceptible to hurricanes and cyclones and those windy conditions and rain and stuff. So that's something that we have to worry about. All these things have been researched upon, and methods are being devised to make Hyperloop safe and less prone to any such disasters, human or natural. Comfort of the passengers while traveling at high speeds and accelerations, especially during turns, is also important, so that they don't feel sick. And so this is something we will have to experience and see. And again, astronauts' experiences can actually have some kind of bearing for common people. When we now, of course, we're not going to put common people through the same kind of G levels as fighter aircraft pilots or astronauts, but the training facilities over there can be used for what's the maximum that common people can put up with, and how they can get used to it. As a matter of fact, most of us actually over time get used to airplane takeoffs and landings, and we do feel sick many times during air travel as well. But still, a lot of people have overcome that. So seats of Hyperloop are designed to provide maximum comfort, as passengers are not allowed to move around because at those high speeds, as well as we need to keep the balance intact. This is again one of those big issues that we have to worry about. A couple of slides on what are the latest development and what we're doing at IIT Madras. So very recently, on the 8th of November 2020, Virgin Hyperloop has successfully tested Hyperloop technology with passengers. Virgin Hyperloop plans to start its operations within the next decade, as I pointed out, and there are a few others in the race, and we are not far behind. The first route is planned to carry travelers for 270 miles between Los Angeles and Las Vegas in 30 minutes. In India, Virgin Hyperloop is planning to have its Hyperloop system safety certified by 2025 and make it ready for passenger operations on commercial projects by as early as 2030. That's the rollout through this decade that is expected. So these are pictures from the Virgin Hyperloop passenger test. Finally, Team Avishkar at IIT Madras that I'm advising is a passionate student team from IIT Madras working towards making Hyperloop a reality in India. The only Asian team to qualify to the finals of the SpaceX Hyperloop pod competition in 2019. Of course, we were planning to win this competition in 2020 because most winners are actually second timers. But 2020 happened to be a different year for the world. As a matter of fact, I think SpaceX actually had changed their plans even before the pandemic. They were trying to redo the track, so they did not launch this competition even as early as late 2019 is when we were expecting them to launch 2020 competition. So that plans changed. So in fact, what we are planning is if it's possible for us to actually run this competition in 2022. So currently working on a new design of a vastly improved pod, which is 3.0. So we have much better new technologies that are patentable or patent applied on the levitation as well as on propulsion using electromagnetism. Researching on novel technologies to employ in the latest pod and researching on tube infrastructure for the Hyperloop. So this is what will actually cut down costs significantly by anywhere between 5 to 20 times. That's the kind of numbers that we are looking at when compared to what Virgin Hyperloop has put out. As a matter of fact, I think Virgin Hyperloop themselves have actually pointed out that this Hyperloop will actually be cheaper than high-speed rail. So when India is actually now aggressively getting into high-speed rail, we now have a very good opportunity leapfrog to Hyperloop instead of actually going through the China route of trying to have the largest high-speed rail network. So we have a very good chance of actually overtaking there, because it is already with Virgin Hyperloop's technology, it is cheaper than high-speed rail. But what we are thinking of is to actually make it much cheaper than that. So with the novel technologies that are being developed, we are competing in the upcoming European Hyperloop Week to be held in Valencia, Spain, in I think this upcoming summer. That's all I have. Thank you very much. I think I'm beginning to see some questions.
Thank you, sir, for sharing your thoughts with us. We are open to interaction and any question from the students, faculty, invitees, and alumni.
There is one question from the student side. So, sir, if you can share the insights on how India would benefit with such a technology, as well as the challenges that India would face. Is basically what is feasible, bullet train or a Hyperloop, or which are the various challenges between the two?
Bullet train, for example, right now is actually a proven technology.
Yeah.
Right? So people always go for a proven technology as opposed to waiting for a new thing to happen. But in our case, I think fortunately a lot of things happen very slowly in India. Right? So by the time we actually do any appreciable bullet train network, Hyperloop would have caught up. All right, the technology would be proven and people would be starting to use. Of course, we also have this problem that it's only if somebody else has used it, we will actually use it. So that's actually what I think is what I call the brown curse. It is a colonial hangover of that we are inferior, which is actually not the case. We could take a march on this. So we will at IIT Madras we'll be taking efforts to push our homegrown technology, prove it just to the same level as international standards. International standards themselves are actually being set as we speak. We think we can actually do this in a much more inexpensive manner when compared to what it takes to develop this technology abroad. So it's a matter of about next 5 years when all of these things can happen, and then we will be proving that this technology is good. And from then on, the next step would be that we actually showcase this in like very short corridors, like a Chennai Bangalore or a Mumbai Pune, Mumbai Ahmedabad, or a Delhi Delhi Agra. I don't know. I'm just coming up with some such sectors which are fairly short, where you can do this travel in let's say about 10 to 15 minutes, 20 minutes, that kind of time frame. Then people will start believing this. In fact, people are actually talking about doing much shorter distances, like for example, the Bangalore airport to the Bangalore city, which is like about 20 odd kilometers, or 40, maybe it's 40 kilometers, let us say, right? So, but that you won't even reach full speeds, maximum speeds for that kind of purpose. So you need to have something of the order of over 300, 400 kilometers, or 200 kilometers for us to reach full speed, and then we'll be able to demonstrate this. So for India, I mean, India is where people are, right? So I mean, I think this question, like what is good for India, whatever is good for India is actually good for the rest of the world. So we need to actually think completely differently now when compared to in the 21st century than what we are used to thinking, right? We have to look at technologies that are good for India, which will become good for the world because it's good for India, because India is where the people are, right? And we have like all segments, all strata of people. So if you're looking at like a middle class with a kind of purchasing power, we have 2 Europes here, okay, or like about 1.5 America here. So it is not something that we can say, why do we do this in India? I mean, why not? I mean, I will actually be offensive and offended that I'm an Indian. I want the best technology in the world. What's wrong? That's actually my answer to this, right? And we need to move people. We need to get like people to get back to their homes from another city at the end of the day's work on a daily basis. I mean, all these things are extremely exciting. So why not, right? So economy has to improve. That's it. Safety, right? So I think can we design it like a jet plane, like jet eject pilot seats? Can we also eject the chamber of passengers, so from Hyperloop when some accidents will happen? So I think the way we are actually looking at it is to not make accidents happen at all, right? So that's the reason why we need to always make sure that we have a minimum distance between the pods. And if something happens to the pod in front, there is like a sufficient braking distance that's available, right? In spite of that, of course, accidents always happen when two things go wrong. So when we always think about like one thing not going wrong, something else may go wrong, and then accidents could actually happen. So the main concern that we have now is that the tube is actually under vacuum and the pod is at atmospheric pressure inside, right? So if some puncture happens in the pod or in the tube or whatever it is, right, that could be a change in the environment which can make it difficult for passengers. But this has been overcome in airplanes. For example, in airplanes, the cabin is pressurized and the outside is actually at subatmospheric pressure that people cannot withstand. So since airplanes have gone through this kind of safety norms, and as I said, we also have space tech that's been implemented. We will have to bring in those safety standards over here and see how to do this in a in an inexpensive manner. This is actually the technological challenge for improving safety. We don't really have a straight answer to this as of today, because the technology itself is getting developed. So once the technology is proven, and in fact, we have had passenger tests that's already been done, which means that it is it's good for passengers as we speak, but it's only about 2 or 3 passengers, or let's say about a handful of them, right? So if you want to now move like continuously, the more we move, the more we are open to accidents, and so we don't really have the safety standards developed yet. So we are in early 2021 at the moment. I think by 2025 we will actually get answers to these questions in a much more precise manner. But the ingredients of the safety standards required are there to be borrowed from air travel and space travel and so on, and high-speed train travel and so on. So all of those things have to be put in place over here in an inexpensive way. That's the way I think about it. We're probably out of time at the moment, and we have run out of questions as well. So is it a good time to say?
Thank you for addressing the questions and clearing the doubts, sir.
Yeah. Thank you very much. Thank you very much for the opportunity.
Now we would like to introduce our next distinguished speaker, Dr. Guruprasad Rao. Dr. Guruprasad Rao is a director and mentor leadership team at Imaginarium India Private Limited, India's leading 3D printing company. His current focus is on design for additive manufacturing for metal 3D printing and medical applications, skill development besides technology mentoring and partnership across domains. Dr. Rao is a technocrat with over 30 years of experience encompassing industry and academia. He holds BE Mechanical with postgraduate in Tool Engineering, Master of Design in Product Design from IISc Bengaluru, and PhD from IIT Bombay. He has taught design in IISc, NIFT, JSS ATE, and NTTF. He was professor and head project office IICD Jaipur. He also teaches courses on emerging technology and its impact at SPGN Institute of Management and Research and KJ Somaiya Business Schools. Dr. Rao is associated with many industry bodies such as CII, FISHI, NASCOM, BIS, IAMF, and Atal Innovation Mission. Now, I call upon Dr. Guruprasad Rao to share his thoughts with us.
Sir, please unmute.
Okay, sorry.
Thank you.
Thank you, Mitali, for this very generous introduction there. And thanks to Somesh Banerjee, the convener of this conclave, Dr. C. Babu of the Management School, Dr. Sarita of the Global Business School, and Harsha Sonar, who was really instrumental in getting me this opportunity. And wonderful to listen to Dr. Satya Chakravarti of IIT Madras on the Hyperloop. Today we are going to explore yet another opportunity wherein very interestingly Hyperloop also could come in handy, because he spoke about the transportation, and we are now talking about something which is a smart technology. And let me try to share the screen now. Can you all see the screen? Let me know if you can see the screen.
Yes, sir.
sir.
It's visible.
Wonderful, wonderful. So today I would like to address the smart technology for all the smart managers which are getting trained at Durgadevi Sarof Management School, because you're taking on the world's new opportunity, and you need to know how world is changing in order to smartly serve your customers. And we are going to talk about learn about the customer also, how customer himself is changing. All business, whatever you do is for that ultimate customer, right? In order to keep them happy. And just now, Professor Satya was talking about how people would, increase the business to 121% if it were to be delivered immediately. So the supply chain, and we are talking about, a new opportunity, a technology which is agile enough to cater to such a need. When the whole business are always chasing the time to market. They wanted yesterday kind of situation always. And we are grappling with another very important thing, a new customer, a person of unpredictable customer. So with these introductory words, I would like to jump. The whole world is looking at a new digitization, which has started long time ago. We have seen the Industrial Revolution 1, 2, 3, and we are at the cusp of entering into the new Industrial Revolution, Industry 4.0. So what exactly is happening is a lot of the technologies which are trying to enable the agile manufacturing. The manufacturing is highly digitized now, and we are going to learn about a little bit of digitization today, and also how it is all coming together, the technology, the customer aspirations, and the new regime, the Industry 4.0, is going to work in tandem to make this happen. Industry 4.0 is like a dream, you know that is going to be coming true because of the technology, you know and that is also matching with the kind of aspiration. So let us look at the customer now, emergence of a new customer. What exactly we are talking about? This customer means who? It is the child born today morning. So what is the kind of thing? It is a child born with a smartphone in hand. So they have a kind of everything is on platter. So they will have a different kind of expectation of things and services. They cannot wait, you know. And so they are the people who want to stand out in the crowd. They want to have something which is very, very uh, personalized to their own needs, right? And they want everything, be it food, it's clothing, or cell phone, or whatever, it's a personal experience. So we sometimes call it as a egonomics. Ego means, ego. Ego means self-centeredness, So what is going to drive future customer is this economics. And these are young people and who have a lot of purchase power, and what they look like, So when you want to come to the persona of that Gen Z, you need to know other forms, the traditionalists, the baby boomers, the Generation X, Generation Y, and this Generation Z. So we are talking about the new customer, Generation Z, wherein there are very few loyalty, and these people may not even know what they want. So once upon a time, it was need which was driving things. Then want, of course, wants are unlimited, we know, and now it is the demand. People want to demand everything, and they want it right now. But they may not even know what they want. Who are we? We are clients. What do we want? We don't know. When do we want it? Now. So you can just think of, a kind of pressure that is going to build up on the manufacturing side, the operation side, the supply chain side, because now customer is demanding it. So in a way, it's a new paradigm shift that has to happen in the manufacturing. And right now, post-pandemic, or we are having a present continuous pandemic with various, new mutations coming, and there is also a kind of a change in the geopolitical situation right now. Polarization. People want to make everything, at their own countries. China, the supply chains disrupted and all that. So our PM has brought in the term Atmanirbhar. So same thing, make in India, make in America has come, make in Europe and Germany has come. So all these, if we see, and they're also grappled with one more thing, the uncertainty that is also being seen with the consumer patterns. So against this background of instability, business leaders can no longer rely on the old response, old traditional ways of line manufacturing. So they have to really strive hard to adapt to new smart ways, which we are going to talk about. So manufacturing world's new agility, a new challenge is agility. So making things, it is not about single minute exchange of dies. It is single minute exchange of products and services, how it can be done. And so that's where we talk of a new term called mass customization. So mass customization something is not about mass actually. It is going to bring mass production's benefit to customization. That's what it means. That means you are able to make a thing for one particular person, but with benefits of scale. Like it will not be very costly, because it is customized. So how do we do it? And this particular need is also stemmed out of these drivers, that is heterogeneous demand, short product life cycle, mature markets, and conscious consumers. Today consumer has all the power to look up and see Karlo Dunya Mutti mein. He has got this smart phone in hand, and they are able to touch and get to any info, right? So conscious consumers, mature markets. There are me too many people, having offerings today. And for a smartphone, I was asking some teenagers how long they use. They said for a year, because then it'll be obsolete. So with a short production cycle, product life cycle, it becomes very difficult how to do it. And also we have something like, money back guarantee, 15 days you enjoy and you can return it, no questions asked kind of thing. How people manufacturing setups will actually cater to this? So they're having another strategy. With the use of technology, they will make everyone party to design group. They co-create with consumers. Okay. So a consumer will have a kind of a feeling that he has designed it, and then he can pay for it, and he can also wait for it for some more time to get delivered. And such a thing is coming. The smart manufacturing is already emerging. So mass customization combines the best of both worlds: mass production, which minimizes the production cost, and customization to provide customers unique product. That is the beauty. And in this, a hyperloop, what we just now had, it can be a vehicle which can bring things much faster to your homes. I'm just imagining how in a medical hospital, the pharmacy is connected to each ward with a tube. Have you seen it? So it's a kind of a hyperloop. It can connect to ward directly. Customer gets immediate delivery from the pharmacy, which is in the ground floor, to any floor of the hospital. They get delivered. Have you seen it? A bottle moves in a compressed tube. Probably you can think of such a delivery to homes also. Why not? So somebody was asking a question, how it is relevant. I see India being a big market, such supply chains, with a hyperloop kind of thing, connectivity to homes could be a reality. We may have to test it. So I have a nearby D-Mart or a big bazaar. How can I order and that gets delivered to my home via a tube? It's a supply chain tube. That's possible. And all this agile manufacturing could be achieved by a new technology, smart technology called additive manufacturing. Okay. In fact, mass customization cycle looks like this, where customers of a particular use group, for example, all people wearing spectacles, can customize and design their spectacles, and it can be made uniquely for their taste and delivered. That continues. So we have something called as a configurator, 3D configurator, which will come into picture, which will help people to kind of design, play with the idea. So it's a true democratizing design, and the experience. And in fact, today, digital manufacturing is bringing a transformation from art to part. So it is conversion of a digital model into a physical model, which you can hold in hand and you can experience it. So it is like slicing and putting it back. And that is putting it back is done by a robot. We call it a 3D printer, right? It is going to assemble it layer upon layer and you get the part. That is the beauty of this technology. And in fact, this technology, people say it is different to different people. Some say SLA, some say call it as SLS, some call it as FDM, some call it as LOM. They're all right. It's a 3D printing technology, right? How blind people explore an elephant. It is like that. 3D printing has different manifestations, right? And today, this technology is very important, for 6 reasons. First is part consolidation. That means a product which is made up of a bill of material of 20, 30, or 100, 300 parts will become one part, bill of material of one. And one can do on-demand jigs and fixtures. One can do lightweighting. Lightweighting is not only for airborne systems, like rocketry or space labs or aeroplane. Today, because the whole IC engine is getting, replaced by EV, not even by hybrid. Even for the automotive terrestrial vehicles, weight has become, payload has become an important parameter to look for, because a battery, whether it is fully charged or fully discharged, it weighs a dead weight. Correct? No, you have to put, you have to live with it. So automakers are looking at how can I now work out. I can go for composite materials, or I can go for smart structures, lightweighting. So lightweighting has become a very important need for today, especially from the point of view of electric vehicles. Complexity, India has its great love for the yellow metal and jewelry, is most complex things, that's one which is really picked up all over the world as a good and need for making one part, you know the economic order quantity is just one and be viable with that. Such a thing has come today. If everyone customer wants his own thing, then the only technology which can probably deliver is this additive manufacturing. And need for customization in medical and healthcare is very high, because we are unique people. We have different anthropometric dimensions. So in order to match healthcare, is having a lot of requirement for such on-demand, production. So whichever is on demand, furthermore, inventory can go digital. There is no need to keep a inventory and suffer with inventory carrying cost. On demand, since you have the just-in-time promise is was a concept, once upon a time, and they can go only up to single minute exchange of dice. Today, the just-in-time you can leave because of technology. That is the beauty of it. And this technology is steadily changing, from its capability to make prototypes at one point, then design validation models at one time. And today, we are able to do the end user parts. That means you prototype and you market that product. Because the life cycle is not so long nowadays, people can afford to make parts, and there are a lot of strategies and technologies which are going to give you a part which is as good as an injection molded part. Injection molding is a means to an end; it's not an end in itself. So today we are able to make the end directly, create it by additive manufacturing. It's the beauty of it. And today what we need is accessible, reliable technology, acceptable quality, material for the real world, controllable systems, predictable results. These are all going to be the drivers. And today, a lot of technologies are becoming open source, and they fuel a lot of innovation. In the maker community, the community run workshops and all. So there are, from Cartesian coordinate, which was patented, we have Delta, Polar, Scalar, so many others which are coming. And here we have variety, but reliability cannot be ensured. So what we need is a kind of a reliable system. And today, a lot of affordability is coming in the form of a desktop machines in every technology possible. You have a desktop today, but a desktop has to be reliable. Only then you can actually go for adoption. And today, there are some low-cost missions. There are high-end missions which are industrial grade, and we need for adoption something which is in between, which can give you reliability, quality, and cost. And that's where some of these technologies are really making deep inroads. They become darling of users. In sectors which are offering good quality at affordable cost. Even the universities are buying these systems so that they can train engineers and prepare them for future. And some of these technologies are becoming key. The metal additive is interesting, and it's a play. Something we need to watch this, because they're going to really help build a smart world. The smart world needs a lot of metal, right? And today we have a research lab to serial production capability offered by some of the OEMs like G Additive, or it could be OS, or it could be 3D systems, or it could be many others, who are making such a beautiful thing. And they're also making it smart, because with a lot of sensors embedded into them, in real-time data can be accessed, logged, and can be controlled. So in a way, they're all becoming 4.0 ready, industry 4.0 ready, which is a regime controlled by sensors, not by people, right? A great amount of automation is coming into this sector, and it is going to make the sector fly. And in fact, smart technology also is enabled by smart design, which is very important. And the smartness is very well put by Gibson. Maximize product performance through synthesis of shapes, sizes, hierarchical structures, and material compositions, subject to the capability of AM technologies. That's how we states it, a smart design. And this can be imbibed by looking at nature, part consolidation, geometric freedom, and biomimicry. These are all the things. You can see the benefits. Looking at it, it's one of the most powerful jet engines. It is by chance, this talk is followed by aerospace, hyperloop expert. I'm looking at a aero engine here, most powerful engine. See the kind of thing, 300 plus parts to 7 parts, and part reduction, design freedom, time reduction, on-demand production of a robust and a complex system like this one. And today, increasingly, some of the best use of this technology is used in the heat exchanges. So thermodynamics can be redefined with the better efficiencies, because of such heat exchangers. The part will look different, organic, more animal-like, or a insect-like, because of the technology optimizations. If you look at the need and what design iterations can be made, intelligent designing is going to have a lot of data driven things, optimizations, and AI. With these tools what is available today, we can have a generative design, how it can be optimized to AI. So designer's role will be to only curate it and test it properly and decide for you, and only offer you what is feasible designs. Those that's the thing. And of course, today there are a lot of new material getting into it. a 500 plus material. At our own Imaginarium labs, we have tried clay, for example. These are some of the things. It is not like a potter wheels. These are really digitally printed, ones. And a smart future world needs complex geometries in small batch quantity. And that's where, if you look at the space of opportunity, the customization, and complexity and volume, we can play around with this, three dimensions of future consumer needs: need for volume, need for customization, need for complexity. Is going to really make it very messy, and there are various probabilities. We can look at various opportunities, and of course, we need to go deep into this to understand. So configurator, a 3D configurator platform can offer you color, material, shape, build your own, assemble, many things like that. And it is very important to have a kind of strategy how to do it. Are we going to have a modular approach, or you keep spares, or it has to be done, or you have a digital model which will drive? Probably, also looking at a manufacturing grid, how quickly you can reach the demand load center. That is very important. And we need to have a preparedness for this, to have a kind of a pipeline, supply chain. You say supply chain will become a demand chain. That is a digital switch. So this will be made real by technology, tools, what they offer, agility, and on-demand production. These are some of the things which are very important. So for this, we need to have a new design thinking. We need to go for customization, need for a small batch quantity, even one part, optimization, and value delivery. And you can see a lot of things are already coming. You can see Gelete, a so-called razor maker, has brought in such opportunity, because of the agile manufacturing capability. You're able to have such things. And you can see new compliant mechanisms, which are so good. I know they are going to have a pick and place actuator is made. It has got a bill of material of one, and it's made as one. Uh, Quite complex, but highly reliable. Such things are going to come, and they will really. And looking at the whole ecosystem today of 3D printers, the individual designer and maker probably will not buy any system. They will depend on a future factory, a cloud factory. So 3 years back, imagine we conceptualized and built our own cloud factory. And to reap the benefit, we never thought we are preparing for a pandemic situation, right? And then when people wanted and no one to ask, they could depend on a cloud factory. So today we are a cloud factory for the world, right? And we have been working for last 1 year. We have been working, fully. And as we am talking, our machines are working 24/7, 365 days. And I'm only, looking at the smart delivery systems like drone, for example, or a hyperloop, which can be connected to every home. Will be even be able to supply better. What else we can think of? In this cloud computing age. So we can see supply chain will become a demand chain. you know so the every customer, he conceptualizes something, or probably in a gamification interface, he's going to play with the interface and order. He pays and waits for it. There is a ownership also. There is no post purchase dissonance here, but he loves the product, and he tells the world on social media, I have designed it, it is going to come, I'm going to show you, and he is going to show. That kind of ownership is there on the design. He owns. And so with the industry 4.0, we are going to have additive manufacturing along with CNC and robotics is going to offer the physical side of the cyber physical system. In a cyber physical system, what can you expect? Who will deliver you the physicality? It is these technologies, the CNC, the robotics, and the additive manufacturing. These are the manufacturing trinity, a deadly cocktail of manufacturing, hybrid manufacturing. that is going to deliver everything what we see for the future, with agility. I think with this, I come to the end of today's presentation. Imaginem has been enabling industry to create value with all our offerings in jewelry, engineering, aerospace, automotive sectors, a venture fund, academy to help industry to adapt these technologies. Then we have solutions, which is going to offer turnkey projects, advice on acquiring hardware, software, building center of excellence in the academia for research, and also making patient-specific offerings such as an implant or a surgical guide or an anatomical model for surgery planning and pre-plan, etc. With this, I would like to stop here, invite your questions. Thank you for the opportunity. I'll push it back to the host.
Yes, sir. Thank you very much.
Thank you, sir, for
Thank
sharing
you,
your
sir.
thoughts with us. We are open to interaction and questions from faculty, alumni, students.
Sir, there are few questions from the student side.
Okay, let me look at the
Yeah.
Q&A.
In the chat box.
Okay. Sir, in today's time, 3D printers are generally used to make prototypes. Well, that is changing. That's what I said. It is changing. Today, we can make a prototype, no doubt, but it can be sold and used in the user context. Use context as a final product, you can use it. Okay. So that is the capability of material, and it's a guarantee it can work in that use context. That is very important. What will be the impact of digitization on employment? Well, digitization, always people had this fear. Trade unions, I remember, they went on strike when robotics were introduced. But today, robotics is a part of our life. So they're serving in a hazardous condition. Same way, when smart factories come up, we have to become smart, and in order to cater to the needs of the world, changing world, I think it's important that we also change. So some of the things what machinery cannot do, what automation cannot do, that's where people, humans are important, taking decision, designing, and working on design, R&D, for example, creating brand, for example. These are all something what your artificial intelligence or smart manufacturing cannot do. So I think they are going to be given some of the job which are not so good, mundane jobs, will be done by those. More intelligent job has to be done by the humans. If they're having mundane jobs, I think those sectors will lose jobs. That's where. And coming to nowadays, we are considering triple bottom line. Yeah, social, environmental, economic aspects of manufacturing. What are the environmental effect due to digitalization? Well, it's a very important question. Triple bottom line, profit, people, and planet is very important. And also, US has its own sustainability, targets for us to achieve as a corporate citizen. Additive manufacturing was somewhat neglected in the beginning. That's why, since 30 years, it has been called as a next big thing. So it's not adopted also, and because of that, people are not looking at the so-called sustainability things from additive manufacturing area. I find that is an area which is a little bit neglected, and people now have identified this is going to create a problem in future. So there has been a lot of work on sustainable material, using biomaterial as a base to build, because if we throw it away, it is going to fill the oceans. In the earth fill, it can create problem with the groundwater, and in use time also it can create lot of health problems. So people are working on biodegradable, biocompatible, and material which can last for long, so that there is no need to reuse them. So design strategy plays an important role. Modular, for example, you're all having smartphone, you cannot even replace a battery in that. Supposing if you make it replaceable, then it becomes more modular. So designers all over the world, particularly Scandinavian countries, are very sensitive to such issues. they are driving the sustainability, the cradle to grave. And we need to bequeath the world to the next generation in its all its greenness. That's very important. And it's good that you mentioned this sector definitely needs such thinking, and it is already going on, and we have a lot of green options today. And as additive manufacturing itself is not subtractive, it is additive. So uh, by you don't have to remove material and make it a scrap, so additive manufacturing has an inherent property to be more energy efficient, because it is energy um, uh, less demand on energy, and it uses just sufficient material to as much required, that also drives the so-called green approach. But well, material, we need to work on materials. Material and software are these going to be the great scope for future, you know and these, because anything which is controlled by computer can be controlled by industry 4.0, sensors and all. So this manufacturing, unlike your lathe or milling machine, which cannot be controlled, today we can control additive manufacturing. So conventional and the new technologies will coexist. Slowly there will be a replacement, and on demand, production has only one option, to go to additive manufacturing. As you can see, that can deliver the agility. Hope I've answered all the questions. I'll push it back to the host.
Thank you for addressing the questions and clearing the doubts, sir.
Thank you. My pleasure. And thank you, Sona, for this opportunity. And would like to see all the bright managers to adopt this technology and be future ready, be ready to serve the industry. Industry needs you. Thank you.
Thank you, sir.
Thank you, sir.
Thank you.
Now we would like to introduce our next distinguished speaker, Mr. Sudeep Mandal. Sudeep Mandal is the founder and CEO of Birsa Technology, a tech startup focused on providing solutions using emerging solutions for small and medium enterprises. Mr. Sudeep Mandal has been in the IT industries for over 28 years and has worked with organizations like TCS, Headstrong, Genpact, Sopra Steria, and Southside Specialty Pharma. He is a keen technologist and passionate about using technology to solve real world business problems. He has done his BTech from IIT Delhi and completed certifications on advanced financial risk management from IIM Bangalore. Now I call upon Mr. Sudeep Mandal to share his thoughts with us.
Thank you, Varsha, for the generous introduction, and good morning, everyone. Let me share my screen, and then we can begin. Can you all see my screen now?
No, sir, not yet.
Okay, give me a moment. I'm probably not doing the right thing. Okay, now it should be there, right?
Yes, sir.
Okay, thank you. Sorry about that. So good morning, everyone. Indeed, it's a pleasure to be amongst all of you. And I must thank Mr. Harshad also for inviting me, because I've had, the last two sessions were very enlightening. And thank you, Dr. Chakravarti and Dr. Rao, for such great, sharing of such information. Really been very, very good to hear about all the wonderful things which are happening around Hyperloop and the digital manufacturing. So the topic that I will be speaking today is on cloud computing and collaborative technologies. Frankly, most of us are so aware of this. This is the year that we have had, that I don't know what more can be spoken, but probably we could share some thoughts about how it has impacted the business and industry. And I plan to share some real life examples when I have been personally involved in turning around business using these kind of technologies. So in terms of the session today, I thought we could start with a little bit about cloud computing, the technology as such, cover some basic facts. I'll share with you some of my thoughts around how it has impacted business and industry, and take you down a case study, which is what I had done in one of my earlier stints with an organization. Speak about collaborative technologies and their impact, and then take some questions and answers. Okay, so moving on, I think the next slide I can skip because this is something that Varsha already covered. This was, I was not aware of the format, so I put in one slide just to talk about myself, but let's just move on. Cloud computing. So I know this probably doesn't represent us anymore, given the year we've had, but we hear about lots of terms when we talk about cloud computing, about SaaS, PaaS, IaaS, private cloud. So hopefully in the next few minutes, and I would be giving you a little bit more clarity on these topics if you're not already aware. So very simply put, cloud computing is like having access to the computing services like storage, hardware, software, databases over the internet. So the cloud here is the internet. And these are provided by what we call the cloud service providers or vendors. And basically, they also provide access to other IT applications and other IT services to customers. So getting access to a pool of hardware and software resources on demand over the cloud is simply what it is. Well, hopefully, this is not what you are thinking, that after all that, you know, as the cartoon says, after all this explanation, it's just don't leave us with the word that it's magic. So let's talk a little bit more about what really is cloud computing. Now, to look at the history, it has been a very gradual evolution that started way back in 1950s when we had the mainframe computers, right? Now, if you know about the mainframe computers, these were large monoliths with all the storage space, the compute power, and we used to connect to them using what we call them as dumb terminals, because unlike the laptops and the desktop, displays that you have, which have a lot more computing power, these terminals that we used to connect to the mainframe were really just a method of accessing that mainframe computers. And there was time slots for allocation to access the mainframe computers at that time. So in a way, you could think of it as like a private cloud where a lot of terminals were connected to a large mainframe computer. So this was back in 1950s. Moving on, in 1970s, the concept of virtual machines came about, where basically the physical servers or machines which were used for hosting computer applications were virtualized, and then you could create images of those machines and quickly scale up and install at different places and use that. So that happened around 1970. Then Salesforce, I'm not sure how many of you have seen Salesforce, used Salesforce, or know about Salesforce.com. Back in 1999, they started delivering their application using a simple website. So that was probably the first instance of a application on demand, or as we will hear the term later, sales software as service. Then the biggest, change happened when Amazon started providing their first public cloud. The AWS was launched in 2003, basis a white paper which was written by one of the Amazon employees, Benjamin Black, where they could where he proposed that we could offer computing services over the cloud like we're providing other services. And that paper was presented to Jeff Bezos, and he greenlighted the thing, and that's how Amazon Web Services came into being around 2003. Subsequently, the other more traditional software providers like Microsoft and Google and IBM jumped into the fray somewhere around 2009. And from then onwards, of course, this whole paradigm has come into being with lots of advances over the recent years. So you can see this has been in existence for more than 20 years. And probably this pandemic was more like a tipping point where all of us got to experience it much more closely and became much more aware of it. So what are some of the key features of a cloud computing paradigm? So the first is resource pooling. It means that the cloud provider pooled computing resources, which means hardware and software, to provide services to multiple customers with the help of a multi-tenant model. So multi-tenant means more than one customer using the same set of resources. The whole demand and the availability is managed by the provider. The customer has absolutely no clue where, from where or what machine is actually providing him the service that is requiring, right? And all this is managed by the cloud service provider very transparently to the customer. Second is on-demand self-service. So as a customer, you have the ability to go and configure and scale up, scale down the demand that you have. And all this can be done through a portal, which is provided by most of these vendors. You can go there, monitor your activity, monitor your usage, and then depending on what is your demand, you could up the usage, you can down the usage. So it's all on-demand self-service. Very easy to maintain. There's practically no downtime because the way the resources are pooled and the way there are backups and hot sites, whenever there is a maintenance need, it can be done while everybody is still online. So easy upgrades. You don't have to shut down the system to upgrade new software or to upgrade the power of the machines or do any bug fixes. Large network access. The user can access the data of the cloud or upload the data to the cloud from anywhere using any kind of device. You're doing it all the time through your smartphones. You use the Dropbox app to upload a file or a picture from your local storage on the smartphone to a Facebook post or to a Twitter post. So there's a large network access which is always available. Cloud computing automatically, it analyzes the data needed and supports a metering capability at some level of services. So we can monitor, control, report the usage, and it will provide complete transparency to the host. Economical, absolutely. Earlier, every time you needed to add more resources or upgrade more resources, you need to go and buy new servers, install them, buy new software licenses. So a huge amount of cost. Now this on-demand method that the cloud has, you could actually scale up based on your demand. You don't have to invest in a lot of the other peripheral things that one would have to, like a data center, the electricity or the energy usage around the data center. All those costs have gone away from you. And with the upgrade in this technology, with advances in this technology area, the cost has come down to as little as $100 to $200 per month for a substantial amount of computing services that you can use. Security, although somebody might have that wrong notion that you're putting, I should not say wrong, but the notion that you're putting all your data and everything on the cloud, so isn't it becoming insecure? But on the contrary, there are very strong security tools and experts who really take care that no security is compromised. On the other hand, you have the whole software and whatever you have is always backed up and available. In case something happens, you can always recover that immediately. So these providers really promise you 99.95 kind of uptime. That's just because they have got the infrastructure and the ability to do that. Pay as you go, I think I mentioned this already many times. This is one of the key features. You can take storage, take computing power basis the need you have. You can estimate how much is my volume, how many users are going to access it, and basis that you can scale up your storage, you can scale up your bandwidth. And all this is almost self-service, right? You could, like I said before, you could go to the portals and manage this all yourself. So that's highly convenient. And all these are measured services. The cloud service providers are always monitoring it. There are tools out there which they provide where you can calculate, estimate, see what is your utilization, what is the trend, and accordingly do the manipulation. So these are some of the key features of any cloud computing service. Now, like I said, you probably have heard of these terminologies: SaaS, PaaS, IaaS. There is also NaaS. So what are all these? What do these all mean? And what really? So let's get a bit more detail into that. Now, if you look at any typical computer or enterprise IT application, the three key modules which are there is first the underlying hardware, where you have the compute power, the storage, the networking. Above this platform is the platform layer, where you provide the operating system, which will basically help coordinate the usage of the underlying hardware, a runtime environment where your applications would run, and persistence or a database where you store your data, right? That's the middle layer. And then on top of it is your actual application, the business application, which again has three layers: a user interface, which is what you interact with; the business layer, where all the logic is written; and a data layer, which is actually interacting and storing your data or retrieving your data. So that is the traditional computer application, the way it is architected. And earlier, all this used to be on the premise, hosted on physical servers, which were managed and maintained by enterprises. With IaaS, what has happened is all these things, the lowest level, the hardware or the infrastructure part, is now being provided as a service. So organizations don't have to physically provision the machine, or don't have to buy this or install the entire networking. This is what is provided by the cloud service provider. You could subscribe to it. You can rent as much storage as you want, and then you can scale it up or down basis your need. Now, some of the key providers in this area, the Amazon Web Services you've heard, Microsoft Azure, the VMware. So that's the typical model, where you are basically renting or subscribing to the hardware infrastructure. Everything else, you are as an organization or as a customer would bring yourself. So on top of this infrastructure, you will load your platform, you will load your software application, which is all in-house. The next one is the platform as a service. Now here, it provides a complete application development platform on the cloud. So now, besides the infrastructure, you can subscribe to the something like a SQL database, or you can even get the operating system like a Linux or a Windows on the infrastructure. So you don't have to buy separate Windows license or a separate SQL license. You could take that on subscription and basis your need from the cloud service provider. So again, they also provide development environments. So if you are developing a software application, you could use that platform and develop your application. So the application developer doesn't have to worry about all these services that he would otherwise need to either install or purchase or build. This is all provided by the cloud service provider. Moving on to the next model, which is called the software as service. This is what we are all most used to. And these are all the applications that we use nowadays, like Google Docs, the Gmails, the Dropbox, the OneDrives, Salesforce is a large, many of you might have used Zoho. So all these are software which are available on subscription basis. running on the cloud, using the cloud infrastructure. You could pay as you go. You can take licenses on the fly. As your demand increases, you could start using these on a subscription fee basis. So that's the three service model on which the typical cloud computing works, and which are used by the different organization. Now, to talk a little bit about the cloud service providers, we've all heard of Amazon, AWS, the Azure. Google is another key provider, and Alibaba, the Chinese firm, Ali Cloud, is the other major player in this market. And Amazon has the largest market share, although recently Azure has made good strides and catching up. Google and IBM, of course, have still some work to do, but everybody is focused nowadays on going to the cloud, providing applications on the cloud, providing more and more features on the cloud platform. So this is almost true. So when you say thunder and lightning, it isn't about God being angry anymore. It's Microsoft and Google fighting in the clouds, right? So that's what is the reality of today. So now coming to the business impact. Now, we've spoken about the Hyperloop, and before that, Dr. Rao spoke about the factory in the cloud. So those are realities. Before that, even during the introduction, we spoke about how all online classes are happening. So there is the whole way of doing business and day-to-day living has had a major change with this whole cloud computing paradigm. A lot of new businesses have come around. A lot of businesses have been able to extend their reach. And I think this whole pandemic, we could survive it much better just because of this technology and the ability of this technology to help us continue our business and continue doing things in a different way, but still sustaining it. To give you some examples, Netflix, we know how the entertainment industry has completely been disrupted by these cloud technologies. Earlier, we used to go to movie theaters to watch movies. We used to buy discs to listen to music. All that is all gone, right? Now everything is on the cloud, streaming services. Netflix is one of the major providers. They use AWS, and it is because the way they use the cloud technologies that last year, in the pandemic year, when they had a major upsurge in subscription, they added 37 million new subscribers in 2020. And that was all possible without causing any disruption because of the way they've used their cloud infrastructure. So adding or supporting new users, new volume, new demand was very seamless for them because they've already built their infrastructure on AWS. Similarly, Uber, which is has disrupted the entire taxi business, again, they use cloud extensively, and that's how they can have their or they can service their motto of always on, always available. And most of these cloud service providers have seen tremendous growth, almost to the region of 25 to 100%. Somebody like a Zoom, as you know, grew almost like their service in this last year has grown almost 169 to 200% from what it was before. So huge amount of impact. Coming to a personal experience, before I founded Visa Technologies, I was heading the technology division of a specialty pharmacy. This is a pharmacy chain based out of Texas. It has about 12 stores, provides very high-end medicines to chronic diseases. And before we set up the technology center for them, technology was a very disjointed effort. There were a lot of software which was being used, a lot of servers, lot of spend on the infrastructure, very disjointed, no coherent single source of truth. So when we evaluated, and there was a huge amount of spend on maintaining this, or anytime we needed to add a new store to the pharmacy chain, there were a whole lot of exercise which needed to be done. And it almost took about a month or probably a couple of months to add a new store to the network. And it was a huge drain of resources and energy. So when we took over the technology center, one of the first things we did was to evaluate whether we could pull everything onto the cloud. And we made our cloud first strategy where we said all the infrastructure would be ported over to the Azure cloud. And we will build applications using Azure cloud services so that the scaling up, the security, the disaster recovery and backup, and the servicing can all be very seamless. And obviously we'll also bring down the cost because it will all be on demand based. So within a period of 6 months, using Azure as our backbone platform, we built applications using Azure compute services, Azure databases, and then also moved a lot of our on-premise hardware infrastructure to Azure storage, and used a lot of software as service like Salesforce and Zoho to provide additional services to the business, and completely transformed the way the technology was being used, and improved the efficiency of the pharmacy by almost 70% and reduced cost by over 50% on technology. So it completely transformed the way that pharmacy was performing. And not only that, it also improved their business because now they were much more agile. Their reach had increased. Earlier, when they used to go to doctors for referrals of prescriptions, they would not really have any way of showcasing what is the status of the prescription. Now with this cloud available technology, they could show it on their mobile phones. So a huge amount of change, and that's the kind of disruption you bring and once you start using these kind of technologies. Now, collaborative technologies, which really, what we are doing now is using that technology. So this is how one can envision meetings happening. So these are basically technologies which enable remote collaboration amongst individuals and groups. Mostly all of them are cloud native applications built on the cloud using cloud services, and primarily for sharing documents, files, ideas, thoughts, and even planning and monitoring projects. There are a lot of tools available. All of us use Gmail. We are holding this conference on Zoom. There are brainstorming tools like Miro, Realtime. These are available. The best part is these are available anywhere, anytime across multiple devices. So you could log in from a phone, you could log in from your iPad, you could log in from any desktop. And I think this whole pandemic has brought these tools much to the forefront. These all have become like Zoom or having a Teams meeting or Google Meet have become verbs rather than noun, as we have seen in the last 1 year. So I really don't need to give many examples here. We've completely disrupted the way we work. Earlier, any meeting, any serious meeting meant traveling, being face-to-face. Now we are having such conferences over the web. Design meetings are happening in my industry, in IT. Whenever we used to start a new project, there are initial phases of requirements and design where we used to insist that we need to go to the customer's location. Now all that is no longer required. You can do everything that you need, including the tracking and monitoring using tools like Trello and Microsoft Teams whiteboarding. You've all used file sharing systems like Dropbox, OneDrive, so it allows you to share your documents. Google Docs allows collaborative editing. So if you want to work on the same document together, you want to see the changes, what's happening, what's being done by the other person, you use tools like Google Docs, the Google Excel. And this has really brought in much more inclusivity, I would say, because we have 91 participants today. We were attending this seminar, but you are recording it. So you can actually spread this whole talk to hundreds more, those who could not attend, or you could, make available the transcripts. So the dissemination of ideas and generation of ideas have been much more democratized, and it has become much more available to a lot more people. So that's been the kind of impact that this has brought in. And in the future, with if some of you have attended the Microsoft, the recent technology show that they did, they're talking about mesh technology, which is also bringing in augmented and virtual reality to this whole concept of online meetings. So you will actually feel your colleague next to you, helping you with some design or modeling, using those Google Lens or HoloLens and other stuff, and using the technologies that Microsoft and these other providers are bringing. So exciting times ahead, a lot of change, a lot of ways things are changing. And with that, I come to the end of my talk. Hopefully it was useful. Open for any questions.
Thank you, sir, for sharing your thoughts with us. We now invite questions from students, faculties, and alumni.
Sir, there are a few questions from the students.
Okay, I'm just trying to see. Just give me a moment. Okay. Yeah, okay. So the questions is, what are the challenges of adopting cloud technologies in India? I really don't see any challenges. We are already adopted it and adopted it quite well. In fact, us at Visa Technologies, we run all our infrastructure on the cloud. We have built our IP on the cloud. So I'm not sure whether I can enlist any technology. Probably earlier, bandwidth, connectivity is a challenge. But with the steps that the government is taking and with the plans that the government has of getting connectivity to the villages, I think even that will go away. So probably at the moment, if I were to think of any challenge, probably it's the availability of the connectivity, because obviously if you are to do things in the cloud, you need connectivity. But the last year has shown us that that's probably become one of our basic needs, like electricity and water. Now bandwidth and connectivity has become even more important, and it will reach the remote parts of India with all the efforts that the government is taking. So we should even overcome that limitation. And once that limitation is done, and with 5G technologies coming in, you can almost be sure that most of the things would now be being done on the cloud. Is there a thing as a private cloud? Yes, there is a private cloud where organizations actually take some storage and configure it in a network which is not accessible to anybody else. So you have the option of using a public cloud application like a Gmail, right? Which is, even though it is secure for you, but it is hosted on the same server as all the, and the other people also have accounts on the same server. But if you are hosting a organizational application on the cloud, you could configure the cloud storage and the access in a way that it is only available to the restricted people. And that's the concept of a private cloud. Data security, yes, that's a valid concern, but frankly, a lot of effort has gone into it. There are a lot of encryption which is happening. There's this debate about WhatsApp's encryption policy and their unwillingness to share it with the government. So measures are being taken. Earlier, there were genuine issues around putting data on the cloud because of the whole concept of now your data is available on the public internet. So a lot of banks and healthcare used to be very wary of using this technology. But now with the technology being advanced, with better security features, with encryption, with other steps being taken by these providers, all those things are becoming gradually less of a concern. So I hope I have answered most of the questions. Anybody else has anything else? More than happy to address it.
Thank
Okay,
you for addressing the questions and clearing the doubts, sir.
thank you. Over to you.
We would like to introduce our next distinguished speaker, Mr. Sukant Padhya. Sukant Padhi is currently working as a Global Chief Information Officer for ATC Tires Private Limited, part of Yokohama Rubber Company, Japan. Before this assignment, he worked as a Chief Supply Chain Officer for ATC during the period 2010 to 2017. He holds a BTech degree in Metallurgical Engineering from IIT Kharagpur and a postgraduate diploma in Industrial Engineering from NITI Mumbai. He has a total of 25 years of experience working with various Indian and multinational companies like BHEL, Asian Paints, Marico, Cummins. His specializations include manufacturing management, supply chain and logistics management, customer service operations, implementation of large-scale IT projects like SAP, ERP, and supply chain systems. Now I call upon Mr. Sukant Padhi to share his thoughts with us.
Thank you, Mitali. Thank you, Professor Somesh Banerjee, Professor Ghosh, and Dr. Babu, and all other faculties and students of DMIMS. Really happy to again come back to this session. I've been, I think, a regular speaker in Opsession for last couple of years. I feel happy to be back again. Before I start my presentation, I must thank Sudev because he has made my presentation pretty easy, because you will find a lot of repetition of what he has already spoken in my presentation, so I can quickly go over that, and I'll come back to actually what we did using this collaboration technologies just through a case study of a new product development process. So I think I'll spend more time on that rather than spending time on the technology part of it. Let me share my screen. Is this visible to you, my screen?
Yes, sir.
Okay. All right. Give me a sec. Just a minute, my slide is not moving. Just a minute. Yeah, sorry. So as Sudev was talking about collaboration, what is really collaboration? In simple terms, collaboration is essentially the process of two or more people or two or more teams or two or more organized within organizations or across organizations working together to complete a task or achieve a goal. So that is precisely what the collaboration is all about. So there can be, in the business context, there are two types of collaboration. One is within the you task forces come together, assign tasks themselves, and set targets, set plans, and align on the plans, and achieve the project objectives. That's the internal collaboration. And then you have external collaborations. There are, like, you collaborate with your suppliers, your service providers, your partners, and other side, you also collaborate with your customers and stakeholders. So these are the two types of collaborations which usually happens within enterprise. Typically, what does the collaboration involves? First, we talk about the technology. What does the collaboration involves? Collaboration involves, first of all, sharing of data, information, knowledge, plans, ideas, and feedbacks. So there is a two-way process of sharing and getting feedback on each of these aspects of data, information, knowledge, plans, and ideas. Then there are assignments of tasks, plans, and targets within the individual team members of that collaborative team. And you have these workflows and the process management, where something needs to be monitored by a team leader, something needs to be approved by a team leader, and something needs to be alerted to carry on the task and the sequences, etc. So there are workflows or process management aspect of collaboration. And then you have meetings, like the various types of meetings. You can have brainstorming meetings to collect ideas, and you can have a review meetings. You can have also celebration meetings. So these are some of the aspects of the collaboration. And when you look at the components of collaboration platforms, the components are like team management, essentially meaning you make a team, you make members of that particular team, and you assign tasks, or you can within the team itself you can form task groups, and you can assign tasks to individual team members or to the task groups, and you can have work streams and all of that. So that is what is typically called as the team management. You can establish relationship between the task groups. You can establish relationship between work streams, or within the task groups, you can establish relationship with the individual team members. So this is called the team management. Then you have a project management, process management platforms or workflows, where you actually make a individual sequence of the task or activity to be done, and you assign the team members or task groups or workstream groups to individual tasks, right? And you establish the relationship between the tasks. Like you could have a start relationship, you could have a finish start relationship, or you can have a start finish relationship. So the various types of task relationships which you can set up as a part of the project management, right? And the next component of collaborating platforms are sharing of documents, or what is called as collaborative editing, which Sudhir was already covered in previous presentations. Then you would have video and audio conferencings, like what we're having today at this part of this session. Then you have sharing of video, audios, images. It's not only the document sharing. You could share the videos, you could share audios, you could share images, right? And you can have, during the brainstorming sessions, you can use whiteboards, which can be again shared by various team members of that brainstorming team. And another important thing is that you are collecting all of these, documents, or videos, and audios, images, etc. So the team members could easily, search for the content or discover, the knowledge in which he wants to apply for carrying out his task. So search, intelligent search is also another part of a collaborating platform. And then there are embedded process controls, like you should have approvals, alerts, exceptions, risks, identification, risk management, escalations. So all these are the various components of a collaborating platform. Now, not having spent much on the collaboration technologies, I will straight away go into the case study where we have used the digital collaboration platforms, and what is the kind of value we have realized. I'll take you through that. So this is typically the case studies about our new product development. And I'll tell you why we have selected this particular process for implementing a digital collaborating platform is based on the opportunity potential which these collaborating platforms have for this particular process. So there are three, distinctive stages of this new product introduction. We have what is called as a new product request initiation, which can come from anybody. There's an idea. It could come from our sales force. It could come from our technology group. It can come from our strategic, initiatives team. So it could come from anybody for that matter. And once this new product request comes in, then we look at the various aspects of, of whether it is feasible or not feasible, both technical feasibility as well as commercial feasibility, all that are done. And then it goes into a development phase where typically the three players who are involved in a development phase are our product development team, our plant technology team, and our quality assurance team. These are the three main drivers of the development process. Then you have the launch, which is basically your, goes into our field and sales guys drive that process of launch. If you look at the stakeholders, on one side, we have plant technology group. The other side, we have design, engineering, and you have development teams, and we have these design and development teams are operated out of 3 geographies and 3 time zones like US, Israel, and India. And we have 3 plants, again from 2 different time zones, one in Tamil Nadu, another in Dahej, and another in Israel. And the product management team, which is essentially the new product management team, they are operated out of our Mumbai office. Then we have the regional sales and marketing team across all geographies and time zones. Like in US, we have our large part of our market. Europe is another big market for us. And then all other countries we call as emerging markets. So these are the 3 markets we operate, and we have the regional sales and regional marketing teams, which they need to also collaborate for this new product introduction process. So essentially, if you look at it, this is the process, the entire process of development. The first, we call it a business case. That means an idea comes in, we prepare a business case, and we call that as per our phase 0, which means the new product is yet to start the whole process. We are looking for a business case, or we are preparing a business case. Once the business case is approved by the CEO, then we are looking at the feasibility. Feasibility, we consider both the financial or commercial feasibility, and we look at the technical feasibility both. And it has to obviously tie up with our strategy. And so there is also a strategic fitment which we look at during our feasibility. Once the project is feasible, which is crosses the gate 1, and then we start what is our design phase. In the design phase, entirely the product, component selection to right up to, your prototype design is done in the design phase. Then it enters the development phase. The development phase is where you're the design on the paper, a design on the drawing enters the manufacturing, and we develop what prototypes and our pilot developments during the development phase. And once the pilot production is done, then we go into your regular production and QA process, and then we once we have the pilot production of clears the quality assurance stage, then we start our launch process in the market. So this is essentially 6 different distinct phases which we have mapped as part of our new production or development. What are the collaborating or collaboration challenges we have been having? If you look at it, we have team members across all functions are involved in that NPDI process. We have sales, marketing, engineering, technology, supply chain, manufacturing, quality assurance, logistics, finance. Almost every function is involved in the new product process. And these team members are across multiple geographies and time zones. We have India, Israel, US, and Europe. These are the primary, geographies or time zones where our team members are present. Right now, we have 3 manufacturing locations in a new product can be, piloted or prototyped anywhere out of these 3 manufacturing plants. We have a supply base for our new products. We might need a new source, or we might need a new raw material for the new product. So we have to source these new raw materials or new sources across India, China, or Europe, US supply base. The NPDI has to go through an average of 200 tasks. If you look at those 6 different phases, these 6 different phases are, if you break it down to their lowest level of task, there are about 200 tasks. Each NPDI needs an active average of 12 team members. We are actually a growth company, which means that a large part of our growth comes from only new SKUs. So we have been 10% year on year of our last 7-8 years, and so our target, stiff target to introduce a large number of new SKUs, which is about 500 on an average per annum. So that's the kind of a target which we have set. Now, if you look at all these complexities and the scale of the operation, managing these, on an average, 500 to get the throughput of 500, we would have a pipeline of about 700, 800 projects at various stages of, the new NPDI pipeline. So managing these many projects and these many team members across time zones, across locations, right, and so many tasks is actually was becoming a nightmare. And everything was happening with emails, with video conferencing, with Excel sheets, audio calls, or your physical meetings and travels. You are typically, when the design team finishes the design, he has to travel to maybe the one of the plants in Israel, and have to have the physical meetings, right? So the collaboration used to happen through all of these emails, video conferencings, audio calls, physical meetings. All these were documented through minutes of meeting. I documents, right from the design documents to your financial feasibility study to specifications, and all of them were all isolated, right? So this was becoming really a very nightmarish experience, without having a very integrated collaborating, digital collaboration, so to say. Now, what was the result? The result was like we're having very long lead time to launch. So it's about, on an average, it was like 10 to 12 months to get one new SKU to launch. And a high number of misses on the target launch dates. It's not only the long lead times, but on an average, like 50% of the time we were missing on the target launch date. So that was a big problem, because we have committed to our sales team or to a certain pilot customers, but we missed the date, and will be missing these planned activities of carrying out trials and so on and so forth. So, and the delay in the launch means the delayed missing of the opportunities of sales. And because of this manual collaborations, right, we used to have high number of prototypes and pilots for launch. For example, there would be average 6 to 7 protos we used to do, or 2 to 3 pilots we used to do. On an average, like 10 production runs to be taken for taking out one new product. And because of this manual collaborations, we used to also have a lot of error and rework, and which is basically resulting in high number of protos and pilots for launch, and which was resulting in poor ownership because there used to be so high misses, so high number of errors, reworks, and iterations. So there was a poor ownership and accountabilities in the team, and the team used to really go through high pressure, resulting again poor teamwork and low morale. So this was the result. So we took this journey on making the whole NPDI digital on a digital collaboration platform, right? 3 years back, 3 to 4 years back, we started this process. And what was the solution we have implemented? We implemented a collaboration platform, which is tightly integrated with our all enterprise systems like our SAP S/4HANA. We have our separate HR system, and all our Microsoft applications like emails and Microsoft Teams and other applications, right? And what is the solution which we implemented? We implemented the parts of the solution is that we have a project management tool, which basically, we have templates of the phase get methodology, which I talked about. So when you create a new idea, the entire template gets copied, and then its tasks actually are created based on the master template, and you create a project, and then you assign the project, the individual or work groups or your task groups or various team members, and then based on the standard lead times, it would give you a project scheduling, right? And then based on the task relationships, right, you manage the workflow of the entire project, right? And you, in between the milestones, you would have project discussions. So we have another feature called project discussion boards, where teams come and review the progress of each of the milestones, and then they track issues, they escalate issues, right? And then you have this sharing of documents, pictures, videos, and drawings, both internal and external. When I say external, it is especially with our suppliers, where we a lot of mold drawings, and these drawings are then shared with our mold manufacturers, and then where they collaborate on the feasibility of that drawing and then make it operationalized later. And as the project progresses, we capture all the data. All the team members not only share the documents, pictures, videos, and drawings, but they upload a lot of other, and they enter a lot of other data as well on a real-time basis. Some of the data acquisitions happens through sensors or happens through various other mechanisms, which is kind of an automatic data capture, and other data are keyed in manually to these applications. These applications also have project reviews, which are like a planned reviews after each milestone, after each major tasks, especially if the task is a critical and the critical path that gets dynamically identified, and those critical paths are reviewed more frequently based on a certain frequency, right? So we have, when the project review is done or mandatory project is reviewed is done, we have made the minutes of meeting mandatory for the team lead to attach the risks. There is a risk format which is there. The team lead has to fill in the risks and what are the actions he is taking to mitigate those risks. And all these this management tool, scheduling tool, and workflow and process tools integrated with our Microsoft calendars and emails and our team. And we also have come out with, giving individual level dashboards where the individual knows what are the tasks pending with him, what tasks are for the day, what tasks are for the week, which are critical, which tasks are green, which tasks are red. All those, dashboards are there for the individual team members, and similarly for the projects and for the entire portfolio of new products. And this is all done through kind of anywhere, anytime, any device. The team members can access, can have scheduled, your video sessions, scheduled audio calls or audio meetings. It is can be accessed from anywhere, anytime, and any device. Just going to give you some snapshots of the solution, where for how meetings are created and how your documents are attached, how action items are identified, and how we assign tasks to those action items, and so on and so forth. These are some of the snapshot of the discussion boards we have for individual projects. This is like your calendar for each of the players, starting from CEO to project teams to project leads, right, and various function heads. This is some of the status which we have for individual projects, at what are the number of SKUs which are attached to each individual project, how many are under design, development, how many are at various stages, right? And what are the top 5 at each stage? Each stage, what are the top 5 SKUs which needs to be pushed? These are all kind of exceptions where everybody is focused on how to make this happen. The various dashboards to see what is the kind of opportunity hopper we have, so that they are kind of have these in their mind while creating their plans. These are some average time statistics, which is kind of there in the dashboard, where the project lead or project team members can look at how their performance have been. And finally, when end of the project, after maybe the new product is launched 6 months down the line, what has been the revenue realization against the forecasted opportunity which we had considered for making the NPD or new product commercially viable or commercially feasible. So we kind of monitor the performance after the launch is done. So with this kind of a solution which is completely digitized, right? What has been the impact so far? It's really helped us in a big way to introduce our new product during the 2020. Like almost 80% of our original targets has been met during this pandemic time. In fact, pandemic forced us to adopt this technology. We had gone live with this system, way back in 2019 or 18 mid, but people were having the usual habit of calling up their counterparts over phone or writing emails, because those are the things very easy for them to do. They were like pretty easy to get connected on a one-on-one and get things done. But combining it to the entire project, collating all the information onto the project was becoming very difficult, and it was not becoming, it was not becoming anybody's baby. And so therefore this pandemic, that did not happen. People were not kind of going to the plant frequently. They just could not go out of their home, even to the office, or to talk about going to the plant to collect the data, or have meetings and discussions. So this really helped us to adopt the technology, because there was no other choice. And now we are seeing that there are signs that this is going to be the normal process. And this really cut down the travel costs which we used to have. And we had found that lead time to launch was over the period of course, last 2 years has been about 20%. We have obviously improved the adherence to the planned launch dates. And more importantly, there's a big improvement on the team morale. There's no more blame game. Everything is very transparent because the data will say that who is delayed, who is not delayed, where is the status of each of the project, which is the critical path. Everything is there at one place. It's like a single version of truth. And this has really helped us to in sharper reviews for the team to focus on the real actions. The dashboards has really helped, and everyone is aligned on the same priority. There is no other I would say understanding problem that I thought these were so many activities, I thought this was priority or this was less priority. So there's no such thing. Everybody is on the same page because it's the same data or same dashboards viewed by the a project leader to functional heads down to the team members, individual team members. Right. So this is all I had to cover. Uh, well, I can take on questions now.
Thank you, sir, for sharing your thoughts with us. Now we are open to questions from students, alumni, and invitees.
Sir, there are few questions from the students and Dr. Sadhna Ghosh in the chat box.
Okay, in the chat box. Which is for me?
First question is from Dr. Sadhna Ghosh. So what difficulties did you face while collaborating across different geographies?
Okay, so the first difficulty was that, for example, one was the, having scheduling, meetings and reviews. That was a big problem because there were so many meetings to be scheduled, and we didn't know what were the meetings which are on which priority, right? So the priorities used to be decided by noise levels. If I am the owner of a particular project from the sales side and I shout on top of my voice, the priority used to be, and I'm more aggressive, the priority used to be, my project, right? Not on the, final objective of how much impact the project is making and what is the status of the project, right? So, so I would say the difficulties earlier of collaboration used to be the schedules used to keep on changing, priorities used to keep on changing, and all were driven by the personality of, the salesperson or the marketing guy who is driving that project. Okay. So now it is all very clear, everything is driven by the critical path, everything is driven by the impact the project will make, and everything will be, driven objectively rather than, those noise factors. That is one of the issues which we used to face. And now, the business rules are very, very coded into our NPDI process. So that is one of the problems. The second problem used to be, I think for the different geographies, especially if I say that the problem, because we used to communicate over emails, right? And most of the information sharing used to happen through email. And if the emails were missed or emails were not able to action out or attached to resulted into a particular action, okay, that was not known, right? So emails to action, that link was missing. So therefore it was very difficult to later on, pinpoint that I have written to you on this subject which was important, and what was the action you took based on that email, and therefore whether you have acted or not, I am not sure. Okay, so that is no longer there. So each of these issues where or each of the difficulties were there when you exchange through a email. That is, quite obvious. The third the third problem which or challenge we used to have during the pre-digital era was that scheduling the VCs. For example, today the flexibility. Like today, the guy doesn't need to go to our office to schedule a video conferencing through our video conference room to our office in say Europe, right? Correct, because their time zones there is a mismatch, and now you flexibility. Now this you can just have a team call right from your office, from your home. So these are the some of the challenges which we had and which has been I would say benefit because of this system. Okay, so compliance is also one of the challenge faced by. Is that to me? How can we tackle the problem? The next question.
Yes, sir, you can answer.
Okay. Compliance is one of the challenges faced by cloud computing. Yes, you are talking about the GDPR kind of issues, correct? What is the kind of compliance when you're referring to compliance? The data privacy and the GDPR kind of compliance are you talking about? Well,
Yes,
I
sir.
think most of these service providers are GDPR compliant, right? So we have not faced any issues so far, right? Did you use cloud services of AWS, Microsoft Azure, or any other service? Yes, we did use. Uh, okay, they already, I think Sudev has already replied. Yeah, I think Sudev has already replied to even the compliance issues that most of these cloud service providers, they give you certificates that they comply to all the regulatory requirements. Yes.
Thank you, sir, for addressing the questions and clearing the doubts.
Thank you.
Now I would like to call our Professor Somesh sir to share his views on this conclave.
Thank you, Varsha. Am I audible?
Yeah, sir.
It was, I think we will all agree that it was a fascinating journey that we all went through today. The process of learning never ends. All four speakers at this conclave were gracious enough to give us some deep insights into both our themes, Hyperloop and the future of transportation on the one hand, and cloud and collaborative technologies on the other. And we are sincerely grateful to all four distinguished speakers for spending time with us. We hope that we will continue to have a long and mutually beneficial relationship. There are a few issues which I would like to perhaps address offline with all four of you. So depending on your convenience, we will take those issues up. I'd like to conclude with a sincere expression of thanks to all four of you.
Thank you so much, sir. Now I would like to request Professor Harshad Sonar sir to propose the vote of thanks.
So thank you, Varsha. All ladies and gentlemen, a very good afternoon to all of you. So first and foremost, I would like to thank our speaker, Dr. S.R. Chakravarti. So he shared his views on introducing the Hyperloop technology. Then he shared his views on the case study of the Chennai and Bengaluru. Then passenger Hyperloop and freight Hyperloop benefits and applications. Then comparison with the other modes of transportation, economics and opportunities, challenges and sustainability issues in the Hyperloop technology. Then I express my heartfelt thanks to Dr. Guru Prasad Rao for sharing his thoughts on industrial revolution, the industry 1.0, 2.0, 3.0, and lastly the industry 4.0. Then new customers, the Gen Z and agile manufacturing. Then his views on additive manufacturing and various recent applications of additive manufacturing and the triple bottom line. Then we are grateful to Mr. Sudhem Mandal on sharing his views on cloud computing, then introducing the Amazon Cloud Services, key features of cloud computing, cloud service models, and collaborative technologies. We are also grateful to Mr. Sukant Padde for sharing his views on the collaboration, then various components of collaboration platform, then new product development case study, and collaborative challenges. Then a big thank you to all of the speakers for wonderful presentation and discussion. We would like to express our sincere gratitude to Sri Ashok Sarafji, Chairman, Dr. C. Babu, Director, DSIMS, Dr. Sarita Vichore, Director, DSGS, and our colleague for their help and support. Our special thanks to Professor Somesh Banerjee, Convener, Opsession 2021, and Dr. Sadhana Ghosh, Co-Convener, for the organization and smooth conduct of this wonderful conclave. Our thanks also due to our Marcom team, Mr. Kamal Magtani and Mr. Vikas Ahuja, for promoting the Opsession 2021 online. We also thank our administration department headed by Mr. Ratnakar Shetty and Ms. Kavita Darji, registrars of DSIMS and DSGS, Ms. Parvati Jayaraman, Ms. Shilpa Gume, Ms. Rashmi Sawant, Ms. Kajol Vora, and Mr. Prakash Galkonda. We would also like to thank our IT support team, Mr. Vijay, Mr. Nagesh, Mr. Ranjit, Mr. Milind, for connecting all of us digitally. So last but not the least, I thank Mitali and Varsha for hosting this event, as also all our student volunteers for their handwork. We would like to thank everyone for being a part of this event. Over to you, Mitali.
With that, we come to an end of our Operation and Supply Chain Management Conclave on Hyperloop, Future of Transportation, and Cloud and Collaborative Technologies. We would like to thank you all for being such a wonderful and patient audience.
Thank you all for helping us to conduct this event successfully. Have a nice day.
So the conclave is
you.
now officially over.